All right, the final set of problems that we used to get ready for the Module 5 test was this half sheet that really focuses on isosceles triangles. So in number 1, we have angle T that we're trying to find, but we see that these are the two legs of the isosceles triangle. That makes T our vertex angle, and angles R and I will be the base angles. The base angles are always congruent in an isosceles triangle, so this is also going to be 58. And since the three angles in any triangle add up to 180, we're going to want to subtract the 258s from 180. And when we do that, we're going to end up with 64 degrees. So that's the measure of T at the vertex there. This is a right triangle, but it's also isosceles. So that makes this the vertex angle and these the two congruent base angles. Subtracting 90 from 180 is going to leave us with 90, and then we want to divide that evenly to split it between the two remaining angles. And that's why angle G is 45. I'm just going to show you what I do on the calculator because sometimes I just say it and I don't actually do it. We're looking for X. We know none of the angles inside this triangle, but we need to get inside that triangle. We've got a linear pair right here. So if this is 100, this would have to be 70 so that together they add up to 180. And this is an isosceles triangle. The two legs are connected at the 70-degree angle. That makes that the vertex angle. Sorry, it was slipped. That's the vertex angle, and therefore these two angles in the triangle are the base angles. So if we subtract 70 from 180, that's going to leave us with 110, and that needs to be split evenly amongst the two base angles. So each of our base angles are 55 and 55, but X is not inside the triangle, it's outside the triangle. So it does make a linear pair with that 55-degree angle. So I know that together they need to total 180. So 180 minus 55 will leave us with 125 degrees for the measure of angle X, 125. Okay, in this triangle, we're looking for the measure of angle A and then the perimeter of the triangle. In order to find the perimeter, I'm going to need to know the value of A. Little a, but let's start with the measure of angle A. So I know two of the three angles, so I'm going to want to subtract from 180 the measures of those two angles, 102 and 39. Subtracting those two angles, we're going to get 39 degrees for the other angle. So notice A is congruent to C. That means that this is an isosceles triangle, and this is my base, and this is my vertex. If that's the vertex, we know it's formed by the two congruent sides, the two legs. So the fact that these two sides are congruent and this one is 13 tells us that A is also 13. This side is A plus 7. 13 plus 7 is 20. So the three sides of the triangle for the perimeter are 13, 13, and 20. And we just want to add those together in order to get the perimeter. And so that's where the 46 comes from, okay? A was 39 degrees. All right, in number 5, they give us the perimeter, and we're going to work backward off of that. I know two of the sides, I'm looking for the third. So the total perimeter is 536. I'm going to subtract from that the two side lengths that we've been given, and so that's going to leave us with 163 for this side. So you can see that these two sides are congruent. That makes it isosceles. That makes L the vertex angle, and that makes M and O our base angles. If this is X, so is M. So I found the length of side LM, that was 163. In order to find the measure of angle M, I need to know what X is. Well, I know if I add any three angles in a triangle, it's going to total 180. And my angles are X, x plus 30, and another x, and that has to total 180. So group up those x's, x plus x plus x. We're going to have 3x plus 30 equals 180. Subtract 30 from both sides, 3x equals 150. Divide by 3, and x is 50. And that is the measure of angle M, 50 degrees. All right, and number 6, it's incredibly similar. We've been given the perimeter of the triangle, but this time I don't know any of the side lengths. I do know that these are congruent though, so if this one is y plus 31, this side will also be y plus 31. So I want to find the measure of angle Q for starters. Well, in my isosceles triangle, these are my two legs. That makes Q the vertex angle, and these two my congruent base angles. So S is also 68. I know 2 of the 3 angles, so I will subtract the 2 68s from 180, and that's going to leave us with 44 degrees for angle Q. Q is 44 degrees. And then we want to find the length of side QR. Well, the perimeter is 344, and if I add the 3 sides together, if I would do this mentally, but I just want to write what I'm doing. The 2 legs that are both y plus 31 and the base, which is y, I know that has to equal 344 because that's the total distance around the triangle. Group up the y's, 3y plus 62 equals 344. Subtract 62 from both sides, and you're going to get that 3y is equal to 282. Divide both sides by 3, and you'll end up with 94 for y. However, that's not the question. The question is to find QR. So QR is y plus 31, and y is 94. 94 plus 31 will give us 125. Okay, and number 7, this is a conceptual problem. Let's just look, we're not proving anything, we just have some questions to answer about the angles over here. So let's come over here and talk about this for a minute. I can't help but notice that these 2 sides are running parallel to one another. I'm going to highlight them. These are parallel, and this is a transversal that is crossing those 2 lines. This angle formed by the transversal and the parallel line, and this angle are alternate interior angles. They're in between the 2 parallel lines on opposite sides. I know those are always congruent. So that's what I get from the parallel lines. Then I notice that I have sides marked congruent. Kind of feels like I should be doing a proof, and I suppose I am informally. But what I also notice is that all 3 of these sides are exactly the same. So what that tells me, let me spin this around, is that this is an isosceles triangle. This is the vertex angle where the 2 legs connect. That makes these 2 angles down here the base angle, and I can go ahead and mark those 2 congruent. If I spin my paper around, the same thing is going to be true over here. The 2 marked sides come up to the vertex angle, so these are the base angles. So I need to mark this one the same as I marked that one. Okay, so I actually have 4 angles that are all marked the same in this picture. Which ones are congruent to DAB, which is this one? Well, this angle is, we're going to call it ABD, angle ABD. This angle is BDC, and this angle is BCD, angle BCD. Those are all congruent to DAB for a total of 4. And then we want to name the angles that are congruent to ADB. Well, ADB is this one. It's the vertex angle. So think about it. If these 2 base angles are equal, I find this angle by adding them and subtracting from 180. I'm going to find this angle the same exact way. I'm going to add this, remember these are equal to these. I'm going to add the same two base angles and subtract from 180. These measurements have to be the same. It's the third angle theorem. So the angle congruent to ADB is going to be CBD, angle CBD. And what do we now know? What can we conclude about the other two sides? Well, this transversal is crossing these two sides as well. And this angle, these are congruent. Well, with respect to the top and bottom, those are alternate interior angles on opposite sides of the transversal. So because we have congruent alternate interior angles, we know, or we can conclude, that AD and BC are running parallel to one another. Okay, I'll set this one up on the back so that if you're interested, you can watch, but otherwise I wouldn't worry about this one. Let's move on. They tell us that PR is congruent to QR. That makes this, appears to be an obtuse triangle. This one on the left, it makes it isosceles. This is the vertex angle. These are the two base angles. They're going to be congruent. And then they also tell us that QS is congruent to RS. I'm going to mark those differently. RS is congruent to QS. That makes this an isosceles triangle, and S is my vertex angle. So these two angles are congruent to each other. Those are my base angles. I'm sorry, this is a little small. Okay, so what are we given? We're told that RSQ is 120. This angle right here is 120. Well, if you subtract 120 from 180, that's going to leave us with 60. And then the 60 is going to get split amongst these two angles right here. So this one's 30 and so is this one. This is 30. It makes a linear pair right here at R. So if this is 30, R has to be 150 right there. And we're trying to find QPR, which is one of the two base angles in this particular triangle. So if you subtract that 150 degree angle from 180, that leaves you with 30, and we want to split that evenly amongst those two angles. So QPR is going to be 15 degrees. Use the diagram to explain why PQR is isosceles. Well, if this is 55, so is this, because they're vertical. And then we can find this missing angle by subtracting both the 70 and the 55 from 180. And that's going to leave me with 55 degrees. So we know it's isosceles because it has two congruent angles. There are base angles, but that always leads to two congruent sides, the sides opposite those angles. So these two sides are